Problem number 4 on 27B, we got a little train, given time and given velocity. First question says, find the average acceleration. So average acceleration, here's a formula for it, right? Acceleration from 2 to 8 divided by the length of the interval, which is c. But remember, if I integrate acceleration, I get velocity. So it's 1/6 times the velocity from 8 to 2. So it's 1/6 times the velocity at 8 minus the velocity at 2, which are those two numbers. And you can see the work the rest of the way. I probably should reduce that, but no big deal. And it's meters per minute squared. It's acceleration. Part B says, does the data in the table support the conclusion that the velocity is ever negative 100? And yes, you need to use this terminology. I think we've had this problem a couple times before. Intermediate value theorem says that since I got a velocity at times 5, which is 40, and a velocity at time 8, which is negative 120, I got to hit all the values between 40 and negative 120, which one of those is negative 100, somewhere in between those two. Part C says, at time t equals 2, the train's position is 300 meters east of the origin station, and it's moving east. Write an expression involving an integral that gives the position of train A in meters from origin at time equals 12, and then use a trapezoidal sum to figure it out. So we started at 300, and all we're going to do is integrate the velocity from 2 to 12, because the velocity from 2 to 12 is going to give me the total distance traveled, or the displacement, sorry, not total distance traveled. So you take that 300, you add it to the displacement, and we'll know where we are. They said use a trapezoidal rule with 3 subintervals, so I'm going from 2 to 12. So the width of the first rectangle is 3, the second one's 3, the third one's 4. And the left-hand rectangles are going to be 100, 40, and negative 120. And the right hands will be 40, negative 120, and negative 150. So I got negative 16 for the left-hand rectangle rule, negative 840 for the right-hand rectangle rule. The trapezoidal rule is the average of those two is negative 450. So I take that negative 450 and add to 300, and I get negative 150. So here's 0. I don't remember if it's north and north, so up and down. But if we've gone negative 450 added to 300, we're at negative 150, which is now, I guess not west, but north and south of the station. And part D is the related rates. Again, a way to mix in another little thing that feels a little different. So they gave us the velocity of this other train, and they drew a little picture at that same time equals 2 that we just used in the last problem. So this guy's here. I might have it backwards. I don't know which one's which, doesn't really matter. So I just, x is this distance here, y is this, z, so x squared plus y squared equals z squared. We're looking for the rate of change of the distance, which is z squared. It's just a pretty straightforward related rate. It's been a long time since we've done related rates, I know. 2x dx dt, 2y dy dt, 2z dz dt. Cancel out the 2's, x, y, and z. So let's see. At time equals 2, the one train is 400 meters north, so I think I use 400 for this one. This one is the 300 is the other distance, which was given to us in the last problem. You remember they started 300 meters. This rate, I found the velocity at time 2, which is 125 for the one train. And then, I think I might have the 400 and 300 backwards, sorry. And then this rate came from the chart. And the other one, that's the velocity at times 2 of the other train. The rest, you can just see me, some arithmetic. These two numbers plus those two numbers divided by the 500. Give me 160 meters per minute. So again, they kind of threw in another little twist there where they can do related rates in the middle of the problem.